Hello friends, welcome back to Our Associates. Today I will show you how we can check overturning for this structure. Basically, this is a gate structure or entry gate for a factory. Here from base to the EGL level, the height is 9 feet 6 inches, which I have considered. Then client's requirement was from EGL to the first slab, the height have to be 25 feet. Then from this slab to this slab, the height is 4 feet. Let me show you the model. Here I have modeled all the openings. Okay. Now let me show you which patterns I have considered in my design. Load pattern, here I have considered live, wall load, floor finish, EQX, EQY, wind X, wind Y. Okay, just go to EQX. Here you can see all the values. If you need to know how this value comes, you can check videos in my channel. I have already 2 or 3 videos on this topic. Then go to EQY, modify lateral load. Here all the values are same, but here I have just selected Y direction. Then go to wind X, modify lateral load. Here I have just changed leeward coefficient. Then I have considered here create all set. Here I have inputted the wind speed. Here I have considered exposure C. I could consider exposure B, but I need more accurate or more better solution for this structure. So I have taken here exposure C. Then other values, how to calculate you can find in my channel. Okay, press OK. Wind Y, modify lateral load. Here all values are same except leeward coefficient, and for Y direction you have to make here 90 degree. Press OK. Press OK. Then OK. Now we can analyze the structure. We will solve this issue by using Excel, and we will also need CAD drawing, because without the weight of soil and footing we can't calculate overturning accurately. Okay, analysis has been done. Now go to the Excel. Here in Excel they need some data from us which are in blue format. Okay, you don't need to place any value in the white rows or columns. Fine. At first we need level and then story height. Okay, let's go to ETABS. From here go to edit stories and grid system, modify show story data. You can see EGL is 9.5 feet, then 25, then 4 feet. We can copy this one, Ctrl C. Let's go to ETABS, then paste them here. But the issue is here you can see that this EGL is in the last position, but here this Excel needs this value of EGL at top. So what we can do, we can take a column here by writing 1, then expand this one and then fill series. Okay, now you have to select this one from this side. Okay, now go to filter and select largest to smallest. Okay, so you can see this time that EGL value 9.5, then 2.5, then 4. Okay, so select them, Ctrl C, and paste them as value. So after this we don't need this thing. Okay, so let's delete them, and we also don't. Okay, now we can delete these unnecessary values for earthquake calculation also. Okay, I mean earthquake load case also. Then from here you can delete them also, but don't delete them. Okay, because it has connection with this row. Similarly, this has connection with this column basically. Okay, now what we need story forces. We need story forces, then it will give us overturning moment. So let's go to ETABS. Here check the unit. Here I am just using US defaults. Go to display, show tables. Then from here we will go to structure output. Sorry, story forces, that means from other output items. If you are using ETABS version 20, in that case you have to select load pattern, load cases and load combination which you need to use. Here I don't need any load pattern, so clear all. Okay, here I don't need to use any combo, so I will make them clear all. Here I will just take one load case, that is wind X. Okay, select OK, then press OK. Now you can see there have several values, but from the location we will take just top. That means just right click of mouse, then select top. Now you can see there have several values, because in wind load, when we have defined wind load, we selected there set all load case to run. Okay, so at first I will select from story 2 to story 1. We will not take EGL because there is no effect of wind load at EGL, that means from EGL to the base. So we will take here from story to story 1. Just copy them, go to Excel, just paste them here. Now go to ETABS again. From here we have to take the value of Vx. Okay, the value of Ex up to story 1. Then copy them, Ctrl C. Select them and paste them. Now see, for story 2, here the maximum value is minus 0.302. Minus 0.302. Minus 0.302. Okay. And this is for story 2 also. Okay. So you can check again from this all, the highest value is this one. And for story 1, the maximum value is minus 2.36. So minus 2.36, and this is for story 1. Note that if you need to get the story forces floor wise, then you have to minus one value from other. That means if I need to calculate the story force for story 1, what we have to do, I will press here equal symbol, then select this one, then minus this one and select this one. That means we are deducting this value to this value, and what will be this value? This will remain same, that means minus 0.302. Okay, now copy them and paste them as number. Fine, and these values are for story 1 and story 2. Now the issue is we need to reverse them. So what we can do, we can write here 1, then drag this one, and from here fill series. Now select them all, largest to smallest. Okay, hope you can understand the procedure. Now for story 1, here you can see after GB there is story 1 and then story 2. So we will copy these two value, and paste them here. Note that not in GB. For GB here the value will be 0. It's not over yet. At first let me calculate the same thing for wind Y. After that we will check here. Okay, here we have to input the weight of the building. So at first ignore this portion. Now go to display, show table, and this time we will select load case wind Y. Okay, okay. Then similarly here I will select top, then from story 2 to the story 1. Control C. Now we don't need them at all, so we can delete them, paste them here, go to ETABS again. This time we have to take the value of BY, okay, up to story 1, then Control C. Go here and paste them. Now you can see for story 2, among the all values, the maximum value is this one. So copy this one. So copy this one. And for story 1, the maximum value is minus 29.052. So select them, Control C, and select here, paste here, Control V. Now what we have to do, we have to deduct story 1 from story 2. So press here, select this one minus this one, okay. Now here the remaining value will be same, that means Control V, okay, fine. Now we can copy them, Control C, Control V as number, then you can copy them also, paste. Now press here 1, then expand it, and from here select fill series. Now you have to select from left to right, then, or you can select from left to right up to this, then sort out largest to smallest. Now we can put them in this column, okay, and the top value will be 0. Now we have to input the total weight of the building here, okay. But note that not only the weight of the structure, you have to include the weight of soil and the weight of footing. At first, let me calculate the weight of structure from ETABS. So from here, go to display, show tables. Here we don't need them at all, just go to joint output, reactions, joint reactions, okay. Now from here, what we basically need, we are getting here only the values for wind Y. So before coming here, we have to define a load combination, okay. We have to define a load combination which is all dead. Here I have taken only dead load, because according to code you have to check this overturning against the dead load only, okay. So you can't take here live load or any other load. So I have made a load combination with scale factor 1, where I have just considered dead, wall load and floor finish, okay, fine. Now go to display, show tables. From here, now we will clear them all, we will just go for load combo, okay, all dead, okay. Now press OK. Now you can see the joint reactions, and the load case is all dead. Now which load you will take? You will take the value of Fz, okay. You will take the value of Fz. Control C. Now come here, and from here you can check or paste them here. We just don't need them at all right now, so we can delete them. Also. So make a sum here, equal sum. Here we have to take up to this. That means here this is coming 332.489. The value is kept definitely, okay. You can check this from here, the value is kept. Now go to the CAD file. This is the plan of footing. We are just going to the elevation. Here you can see that the section, the plan of first footing is 18 feet 10 inch by 12 feet. 18 feet 10 inch by 12 feet, and this one is this is same, and this one is 12 feet by 12 feet. So let's go to calculator. At first I need to calculate them. 12F, okay, 12F feet multiplied by 12F feet. Here the thickness of the footing is 18 inches. That means I will take 1.5. So this value is in CFT. We have to convert them in kilonewton. I need to make this calculation in kilonewton because unit weights are given in SI unit in our code. So just divide them. 3.28 multiplied by 3.28 multiplied by 3.28. Okay. So here you get 6.12 meter cube. Now, what is the unit weight? What is the unit weight of concrete? What is the unit weight of concrete? Here I have taken a chart for unreinforced concrete. Okay, for unreinforced concrete, if it is stone aggregate, then unit weight will be 22.8, and for brick aggregate, this will be 20.4 kilonewton per meter cube. But this is unreinforced. Here they have written that for reinforced concrete you can add some more values, but we are just taking here brick aggregate. Okay, we are not considering here stone aggregate also. Okay, just we are taking here 20.4 kilonewton per meter cube. So multiply this one with 20.4. Okay, so here we get 124.87 kilonewton. Just write down 124. Just write 124 kilonewton. We will convert them. No issue. Then for the second one, which one is here 18 feet 10 inch by 12 feet. Okay, 18 feet 10 inch by 12 feet. So 18.83 multiplied by 12 feet. Okay, 12 feet. Okay, multiplied by 1.5. So divide this one with 3.28. Okay, so this is the weight. Sorry, this is the area in meter cube. Now we have to this is the volume in meter cube. Now we have to know the unit weight, which is 20.4. Okay, 20.4. That means here 195.94. So I will take 195 kilonewton. This is the weight of second footing basically. Okay, now come to soil. If this is a soil, try to understand carefully. 18 feet 8, then this is 12 feet. Sorry, 18 feet 10 inch, and this is 12 feet. Okay, and here the total from EGL to the bottom, the height is 9 feet 6 inch, but 1 feet 6 inch is depth of footing. So what will be the remaining portion of soil above the footing? Let me check. This will be approximately 7 feet 9. How? Okay, this is considering the 3 inch. Okay, just take 7 feet 9. Okay, hope you can understand. This is the soil which will rest above the footing. So at first I will take 12F by 12F into 7.75. that means 7 feet 9 inch. Divide them by 3.28 into 3.28 into 3.28. Okay, this is the volume. Now multiply this with the unit weight of soil. Here you can see that we can take the unit weight of soil as 15 kilonewton per meter cube. For sand, here just I am taking here 13 or 13.5. Okay, so multiply this one with 13.5. What we get? We get 426 kilonewton. We could take 427, but we are taking here 426. Okay, fine. This one is also in kilonewton. Now here comes another portion, which is for this bigger footing, which is which is 18 feet 10 by 12. 18.83 into 12 feet into 7.75. okay, 7.75, which is the height of soil above the footing. Okay, then divide this one, 3.28 into 3.28 into 3.28. okay, now multiply this one with 13, so we get 645. Let me check the another one again, I mean this value, sorry for the interruption. 12 into 7.75. okay, then divide this one, 3.28 multiplied by 3.28 multiplied by 3.28. okay, then multiply this one, 13, yes, 4 1 1, maybe that time I have taken 13.5, doesn't issue. So this is the weight which are totally coming on the base. Now here, from here I need to make a sum. Here in kilonewton the total weight is approximately this value. Now if we check conversion from kilonewton to kips, here you can check, in kilonewton we have the value 1375, so 1375. okay, that means 309.11 kips. We will take here 310, doesn't matter, 310. That means our total value is 310 and another one is 332. okay, 332. So total weight equals, total weight at the bottom is this weight, that means 642 kips. Then copy this one and paste this here, okay, also this will be pasted here. Now you have to calculate another thing, which is center of mass along x direction. For this we have to go to ETABS, so go to display, show tables, then from here we can check center of mass and rigidity. okay, now from here you can check that for story 1 in x direction the center of rigidity, they have different sizes of slabs. So for x direction the value of rigidity is different at different floor, but for y all values are 3 because this is 6 feet. Okay, let me check with this 18.55. It's okay because this is greater than 1.5. Then let me check with 20.55. This is more safe. Then let me check with 21.46. okay, which is greater than 1.5. Now come to this point. Here you can see the center of rigidity is at 3 feet for all the floor, so we can calculate 1. Here if I give here 3, you can see that the value is 1.90, which is greater than 1.5. That means for overturning due to wind load our structure is safe. This value could be more if we took the actual value of concrete, okay, than the actual value of soil, which was 15. This value could be at least 2.12 more. okay, but this is greater than 1.5, that means it's 100% okay according to code. Now let's go to earthquake. This will not take much time. Just go to display, show tables, select load case. From here we can select EQX, press OK, then press OK. Here you have to select, here you have to select story forces, display show table, story forces, okay. One load case, no combo, we don't need any combo, press OK. We don't need here anything, clear all, okay. So just one load case, EQX. From here I will take top level, okay, I will take the top, and these values are also story 2, 1, so we have to revise them or reverse them. So from here just paste them, paste this value here, then go to ETABS again. This time we are taking Vx, so copy them and go to ETABS, sorry, Excel. Now what you have to do, you have to do equal this floor minus this floor minus this floor, then you can, okay, now this value is Control C, Control V. Now copy them, Control C, and from here Control V, or paste them as number. Here this is the story 2, I need them also, paste. Now we have to reverse them, so paste here 1, then okay, drag them from here, fill series. Now select from the left side, then sort them as large to small. Okay, so you can see Control Z, select them these values also, so this will be better. Okay, so EGL story 1, story 2, so this is the real values, so select them and paste them. Okay, here story height we have to take them from here, no issue, we can take this value from here, story. So you can see for okay, here we have to also input the weight of building, that means Control C, and here Control V, paste. So you can see this is, I am extremely sorry to say that when I have inputted the value here, you have seen that this value is minus 31.97, that means which is less than 1.5, that means not okay. But basically this was my mistake. If you see here I have taken the wrong value of story height. Okay, these are wrong value, go to here again and from here copy them or press Ctrl C, extremely sorry for that, then paste them here. This time you can see the value is greater than 1.5, that means this structure is safe against the overturning in x direction. Okay, let me show you back. Here I have used negative value, or this value maybe I have copied, or this value. So in that case they shown them this negative value, but if we go forward, when we are putting the accurate value, this is fine. Now you have to input the center of mass. These are same for all of them, but you can check them also. Center of mass and rigidity 18.5, 20.55 and 21. Let me show you for the lowest one, that or let me show you all. 18.55, 18.55, okay, then 20 point something, then maybe 21.5. okay, for all values this is greater than 1.5. Let's go to y direction, which is the main factor here, because you can see that our structure is stiff in y direction basically. So let's go to Excel. Here we have to take the story forces. Okay, here you have to take the story forces. So go to ETABS, from here just cut it down, display, show table. From here select load case earthquake y. Okay, okay. Now from here I will select story forces. I will just take top locations. Okay, now from here copy them all, Ctrl C, then paste them all, okay, then from here just do them, deduct from the upper value minus 1, sorry, minus 9.012, then drag this one, and this value will be same as it is. Now copy them, Ctrl C, or from here you can copy them, Ctrl C, then paste them as value. This is for story 2, 1 and EGL, right? So you can copy them, paste them here, then write here 1 and drag them, then fill series. From this side select them all largest, so it's okay, Now go to here and copy them or paste them. Okay. So for this you can see the value is 15.33. The value is 15.33. So we can say for y direction also our structure is totally safe in overturning for x and y direction. Okay. One question may arise in your mind that if our structure is failing in overturning issue, then what we can do? We can increase the weight of our structure if possible. Suppose if this is a factory building, you can increase its weight at periphery wall. That means you can use 10-inch wall. But for this structure, what I could do? If this structure was failing in overturning, what I had to do? Basically, there was no other option. I could try with some more depth of soil cutting or soil excavation. If this also fails, in that case I had to provide pile foundation. So this is the final concept. You have to increase the weight, or if it is not possible, then you can increase the height of soil excavation, or if this is not also become possible or not be possible, in that case you have to provide pile footing or pile foundation. Thank you again. That's all for today. See you in the next tutorial. Thank you.